A post-mortem on the June 24, 2019 Cloudflare outage, a DevOps postmortem. It's June 24, 2019. You're sitting in front of your monitors when the internet suddenly starts to behave like it's losing its mind. It isn't just a localized glitch or a minor server hiccup. It is a massive, sweeping failure of connectivity that feels like the digital floor is falling out from under everyone at once. By 10:47 UTC, Cloudflare engineers are staring at their dashboards and seeing something terrifying: a massive spike in error rates across their entire network and a catastrophic drop in traffic. Somewhere out there, the backbone of the web is buckling. The scale is staggering. Not just one site is down, but chunks of the internet are being rerouted into a void. We don't know it yet, but someone's simple configuration error has just triggered a BGP nightmare involving over 200,000 IP prefixes. The doors are slamming shut, and millions of users are suddenly hitting walls. Think of Cloudflare as the massive, invisible gatekeeper for a huge chunk of the internet. They sit in front of thousands of websites, handling security and speed, so those sites don't have to deal with the raw chaos of the open web. When Cloudflare goes down, it's not just one site failing. It's like a major highway interchange collapsing, causing traffic for thousands of different destinations to grind to a halt simultaneously. On June 24, 2019, this gatekeeper faced a massive failure that wasn't caused by their own code, but by the very plumbing of the internet itself. Specifically, at 10:34:25 UTC, a catastrophic BGP routing leak began. This meant the road signs for the internet were suddenly lying, telling data to take massive detours into dead ends instead of reaching Cloudflare's servers. For any junior dev, this is the ultimate "why does the network do this?" moment. For most of the morning on June 24, 2019, everything was humming along just like any other day in the infrastructure trenches. Cloudflare's network was moving millions of requests, shielding sites, and serving content across the globe without a hitch. But at exactly 10:34:25 UTC, something shifted deep within the plumbing of the internet. It wasn't a bug in a line of code or a failed deployment on a local server. It was a ghost in the routing table. A customer of DQE Communications, an entity called Allegheny Technologies Inc., began broadcasting a massive lie to the world. They started incorrectly advertising over 200,000 IP prefixes. Because Verizon, a major transit provider, failed to filter these routes, they were propagated across the web like wildfire. The internet's foundational routing protocol was being hijacked by a configuration error that was about to turn the global map into a maze of dead ends. It was June 24, 2019, and for most of the world, it was just another Monday morning. But at 10:34:25 UTC, a silent catastrophe began unfolding deep within the backbone of the internet. A customer of DQE Communications accidentally broadcasted a massive BGP routing leak, incorrectly advertising over 200,000 IP prefixes, including those belonging to Cloudflare. By 10:47:7 UTC, the engineers on the front lines started seeing the red flags flash across their monitors. It wasn't just a minor blip. They were looking at a sudden, massive drop in traffic coupled with a spike in error rates across the entire network. The internet was effectively trying to shove Cloudflare's data into a pipe that couldn't handle it. In those first few minutes of chaos, the team realized this wasn't a local bug or a server crash. Something fundamental about how the world reached their doorstep had just broken. It started with a single, catastrophic mistake in the routing table, a classic BGP leak that turned the internet's map into a maze of dead ends. At 10:34:25 UTC on June 24, 2019, a customer of DQE Communications began broadcasting a massive lie to the world. They didn't just misroute a few packets. They incorrectly advertised over 200,000 IP prefixes, including those belonging to Cloudflare. Because Verizon failed to filter these erroneous routes, the leak propagated across the globe like a virus. By 10:47 UTC, the engineers saw the red flags. Traffic was plummeting while error rates spiked across the network. The cascade wasn't just a local glitch. It was a systemic failure where legitimate traffic was being dumped into an unprepared network that couldn't handle the load. It took until 1100 UTC for the transit provider to start pulling those toxic routes back, finally starving the fire of its oxygen. So, what actually broke the internet that morning? It wasn't a bug in Cloudflare's code or a hardware failure. It was a fundamental flaw in how the internet talks to itself. At exactly 10:35 UTC on June 24, a BGP routing leak began, originating from a customer of DQE Communications. This specific entity, Allegheny Technologies, Inc., erroneously advertised routes for over 200,000 IP prefixes. Because Verizon acted as a massive transit provider and failed to filter these updates, they propagated those lies across the global backbone. Essentially, the internet was told that Cloudflare's traffic should be routed through an unprepared network that couldn't handle the load. By misdirecting these huge swaths of data, the leak effectively orphaned Cloudflare's infrastructure from its users. It was a textbook example of how the inherent insecurity of BGP can turn a localized configuration error into a massive, multi-network blackout in a matter of minutes. When the BGP route leak hit on June 24, 2019, it wasn't just a localized glitch. It was a massive, systemic failure of the internet's plumbing. Because a customer incorrectly advertised over 200,000 IP prefixes, traffic intended for Cloudflare was hijacked and dumped into an unprepared network. The impact was immediate and widespread. By 10:47 UTC, the team saw a massive spike in error rates across the entire network as traffic began to vanish. For about 40 minutes, a significant portion of the internet effectively went dark for Cloudflare's customers. It took until 11:20 UTC for services to be fully restored after Verizon finally pulled those rogue routes. In less than an hour, a single routing error turned a massive swath of the web into a dead zone, proving just how fragile our interconnected infrastructure really is when the underlying protocols aren't locked down. At 10:47 UTC, the alarm started screaming as Cloudflare engineers watched traffic plummet and error rates spike across their network. It wasn't a localized bug. It was a ghost in the machine. By 10:52 UTC, they pinpointed the culprit, a massive BGP routing leak originating from a peer network. Someone had accidentally advertised over 200,000 IP prefixes, including Cloudflare's own, sending traffic into a black hole. The team had to move fast, coordinating with transit providers to stop the bleeding. By 11 UTC, Verizon began pulling those erroneous routes back from the wild. It was a tense dance of manual intervention and high-stakes communication with upstream partners. By 11:14 UTC, the traffic started flowing back into the right pipes, and by 11:20 UTC, they confirmed services were fully restored. They survived it, but the scars left behind a grim reminder of how fragile the internet's foundation really is. The fix wasn't a line of code in a dashboard. It was a massive exercise in diplomatic firefighting and network plumbing. Once the team pinpointed that Allegheny Technologies had leaked over 200,000 IP prefixes into the wild, they had to get Verizon on the phone immediately. By 11 UTC, the transit provider began pulling those poisonous routes back from the global table. It was a frantic period of coordination with multiple upstream providers to ensure traffic didn't just find another dead end. By 11:14 UTC, the needle finally moved, and traffic started flowing back into Cloudflare's network as the incorrect paths were purged. To stop this nightmare from repeating, the focus shifted toward the structural rot of BGP. They pushed for more robust filtering and the adoption of RPKI resource public key infrastructure to ensure that a single customer's mistake couldn't hijack the internet's map again. Look, if there is one thing this mess teaches us, it's that the internet's foundation isn't as solid as we like to pretend. When a single customer at Allegheny Technologies leaked over 200,000 IP prefixes into the wild, it exposed just how fragile BGP really is. It's an old protocol, and frankly, it's insecure by design. We saw what happens when transit providers fail to filter those routes. Suddenly, traffic isn't just lost, it's hijacked or dumped into a black hole. The takeaway here isn't just be careful. It's about aggressive defense like RPKI to validate who owns what, and demanding rigorous filtering from your upstream partners. You can't just trust the neighbors to keep their house in order. You have to build the fences yourself. In this game, a single misconfiguration at a peer can become a global catastrophe in minutes if you don't have the guardrails in place. That's how Cloudflare turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.